Let's say you just got a new job and you are making $10 an hour in that job. Okay? Now let's then suppose that you're working 8 hours a day, pretty normal work day, and then you do that 5 days a week. And you want to figure out how much money do I make in a week? There's two ways to do the problem. The first way, imagine if we took how many hours you work in a day and multiplied how many days are in the week. That would give you how many hours a week you're working, which would be 40. Take that number, multiply how much you make an hour. So you make $10 an hour and you work 40 hours a week. You would bring home $400 a week. Another way to do the problem is to think about, well, if you work 10 hours a day and you do that for 8 hours, if you make $10 an hour and you work for 8 hours, you would make $80 a day. Now, how many days a week do you work? 5. So if you make $80 a day for 5 days, that would still be $400 a week. Notice that no matter which way you do it, whether or not you figure out how many hours a week you work or how much money you make a day, you end up with the same answer. Alright, another problem. Here we're just imagining you're looking at the back of a truck, maybe like a semi, and so there's actually 6 semis here in the blue. Each semi holds 4 baskets of apples. Okay? And each basket has how many apples? 1, 2, 3, right? So you got 6 trucks in the blue. You have 4 of these baskets in each truck, and each basket has 3 apples. And you want to know how many total apples there are. Again, there's actually 2 ways to do this problem. Let's go ahead and take a look. First way is to go ahead and figure out how many total baskets there are. Well, if there's 4 baskets in each truck and there's 6 trucks, that would actually make 24 baskets. Okay? And once you figure that out, you can go ahead and figure out, well, if there's 24 baskets and there's 3 apples in each basket, 3 times 24, 24 plus 24 is 48, plus 24 is 72. Therefore, you would have 72 apples. Let's go ahead and look at the other way of doing this. Now, if there's 4 baskets in each truck and 3 apples in each basket, let's go ahead and look at this picture one more time. So 4 apples in each truck and 4 baskets in each truck and 3 apples in each basket. Suppose you want to know how many apples are in a truck. Well, that would just be 4 times 3. So there's actually 12 apples in each truck. So 12 apples in each truck, and there's 6 trucks. 6 times 12 also gives you 72. So there'd be 72 apples. So again, it doesn't matter whether or not you figure out how many baskets there are first and multiply by apples in a basket, or if you figure out how many apples in a truck and multiply by the number of trucks, you still get 72 apples. Again, 2 ways to figure out exactly the same problem. Alright, now suppose there's a neighborhood, and up here we have we'll call it the north side of the street. Down here is the south side of the street. Now let's think for a second. So how many sides of the street are there? There's 2, right? Now let me ask you this. These are townhouses connect to each other. How many townhouses are on each side? If you count them, it's 1, 2, 3, 4. And suppose that in each townhouse you have 3 people living in each townhouse. 1, 2, 3, 1, 2, 3. And we want to know how many people live in this neighborhood. Now, this is a simple one. You could actually count the number of people, but just imagine if it was a huge neighborhood. Just imagine if there were, let's say 50 townhouses on each street, and there were 8 people living in each. Okay, then it becomes a little bit harder. So you can see why this is important, because we don't always actually have to multiply out all the numbers to figure out this particular principle. Anyways, suppose we first just want to figure out how many townhouses there are. That's pretty simple. We would take the number of sides of the street, which is 2, the north side and the south side, multiply by the number of townhouses on each side, and that would give us 8. So there's 8 townhouses. Then we know that there are 3 people in each house. 8 times 3 is 24 people in this neighborhood. The other way to figure it out is to figure out how many people live on each side of the street. Well, if there's 4 houses and 3 people in each house, that's 12 people on each side. How many sides are there? 2. If you multiply 2 times 12, you get 24. Again, 2 different ways to work out the same problem. We both end up with 24 people. The name of this concept in math is called the associative property of multiplication. We've already looked at the associative property of addition. Remember, the word associate means the way that we group. So associative property of multiplication. What we will learn is it doesn't matter what order you multiply numbers, you end up with the same answer. And we're only going to look at 3 numbers, although I will say it works for 4, 5, 6, 7, 8, however many numbers you want to put together. Let's go ahead and look at the first example, official example. 8 times 9, so we're going to multiply those first, times 2 is equal to what number times 9 times 2? And again, some of you can already go ahead and know exactly what that is, but let's go ahead and just formally do it. Just like associative property of addition, we're going to go ahead and remove the parentheses, or like I said before, it's kind of like saying we're going to ungroup them. And once you remove parentheses, it's real simple, right? We can go ahead and see exactly what goes in that box. And just to be sure, 8, right? 8 times 9 times 2 can only be equal to 8 times 9 times 2. You can't stick anything else in the box. Doesn't make sense. Let's go ahead and look at the next example, including negative numbers. This is something that might be a little different for you as far as notation. Negative 12 times 4 times negative 3. Now you might say, how do you know there's a times there? Well, whenever you have 2 parentheses next to each other, so like this, that actually means multiply. So let's just say, for example, we had 2 and then a 3. That's the same as 2 times 3, okay? It's just a different way of multiplying, basically, or writing multiplication. So negative 12 times 4 times negative 3 is equal to negative 12 times, and then this time we're going to group 4 times whatever this unknown number is, which, again, a lot of you probably know what that is. So we're going to remove the parentheses, take them out, and notice I went ahead and stuck a multiplication sign there because it's when you group 2 parentheses like that, you can assume there's a multiplication sign there. Imagine if I didn't do that and I just removed the parentheses, it would say minus 3, and that wouldn't look right. So we need to go ahead and put that multiplication symbol in there. Is equal to negative 12 times, now again we're going to remove the parentheses here, and we can already kind of see what's going to go in that box. So down here for solve, negative 12 times 4 times negative 3 is equal to negative 12 times 4 times, you can go ahead and see exactly what's going to go in that box, which is negative 3. Now we're going to go into fractions, and I love this example and I love the visual that accompanies it. Let's go ahead and read this together. We have positive 6 times what number times 1/3 is equal to positive 6 times and then 1/2 times 1/3. Again, we're going to go ahead and remove the parentheses. And so we have 6 times what number times 1/3 equals 6 times 1/2 times 1/3. By now, many of you can probably already see the answer. In other words, 1/2 is going to be your answer. And again, whatever's on the left has to be the same as what's on the right. Now you might be saying, why does that work? I mean, I understand whole numbers, but why do fractions work? Well, let me go ahead and show you. Okay, imagine you have a pizza, right? And the pizza has 6 slices. Okay, so I'm going to have to try to point this the best way I know how to. So here's your pizza, has 6 slices. Imagine if you cut that pizza in half. Okay, so you're actually multiplying by 1/2. And you would have 3 slices. Now imagine again if you cut that into 2/3. Okay, so you cut the pizza in half and then you cut it into thirds, which by the way is the same as multiplying by 1/3. You would end up with, actually that'd be 1/6 of the pizza, right? Now, Let's imagine you do it a different way. Instead of cutting by a half and then a third, imagine if you just understood what 1/2 times 1/3 was first. What is 1/2 times 1/3? Well, that's actually 1/6. So imagine instead of multiplying by a half and then a third, imagine if you went ahead and just multiplied by 1/6. You would also end up with a sixth of the pizza. So no matter which order you do that in, you end up with a sixth of the pizza. So down here we just went ahead and just multiplied by 1/6, and up here we cut it in half and then by a third. So we multiplied in different orders, right? Both end up with the same amount of pizza. Hopefully that visual helps you. Okay, now we're going to look at the formal way of writing the associative property multiplication. Again, we're moving to the abstract. We're going to think about any number times another number. We're going to multiply those first and then times a third number. So again, if you struggle with variables or abstract numbers, I guess you could say, you could go ahead and just put in your own numbers down here. Say 2, 3, 4 to help you. Okay, we're not going to do that. We're going to leave it there. I'm just saying if that helps you for a while until you realize that any number will work, good for you. Go ahead and do that. So a times b and then times c is equal to what? Times, and then we're going to multiply b times c first here. So on the left we multiply a and b first. On the right we multiply b and c first. Okay. Again, we're going to remove the parentheses for the first step. Just take those right away. And then you can go ahead and see a times b times c can only be equal to a times b times c. Now, if you like geometry or if you like visuals and boxes, maybe this visual of a box will help you. Before we do the ABC though, let's actually look at a specific box. For this particular box, it is 5 units high. Okay, if you live in the US, that'd be, you could say 5 feet. If you live in the UK, you could say 5 meters. Okay, or 5 centimeters, a small box, doesn't matter. Okay, so 5 units tall, 2 units wide, and 9 units deep. Okay, now you could just multiply all the numbers together, but let's actually look about like how volume works. So if we multiply the 5 and the 2 first, that will give us this green shaded area, which would be 10. So 5 times 2 is 10. Now, if we look at how deep the box is and multiply it by the depth, so the area of the green shade on the box times 9, that's going to give us a volume of 90. So you've got a bunch of those areas, in fact 9 of them. 10 times 9 would give you a volume of 90. A different way of looking at it is multiply the width, which is 2, times 9. That would give you the area of the base. Now if you take the area of the base and you multiply up by the height, that will also give you the volume. So over here you would take area of the base 18 multiplied by 5, and guess what? That's also 90. It's two different ways of finding the volume. You get the same answer no matter what. You get 90 either way. Now let's look at the more abstract, which is the last thing we're going to look at. Over here we have the shaded area of the tall area, a times b, and then we multiply by c. And over here we find the base area and then we multiply by the height. So here's the base area times the height. The point I want you to see here is these are exactly the same boxes with exactly the same volume. Two different ways of finding the volume. In essence, that's the commutative property of multiplication. Doesn't matter what order you multiply the 3 numbers, or the 4, or the 5, or the 6, you end up with the same number.